Hey physics, I wanted to go through this distance versus displacement slideshow just to make sure that everyone, if you need some guidance with it, that you can get that guidance. So, the big idea, that's the difference between distance versus displacement, is that distance is going to be basically like the path length. So like if a bee goes 2 feet here, 6 feet here, 8 feet here, it's going to be 2 plus 6 plus 8, which is going to be 16 total, right? Whereas the displacement is just like if you were to take a snapshot of the bee when they're there versus the bee when they're at the final spot, that's going to be their displacement. And something that's important with displacement is that you're always going to say what direction they're moving in. So, so here's our first problem. So here's Frederick. He's going to ride his bike around the block. If he rides out of his house west, the sidewalk circles his block and brings him back to his doorstep 1 mile later. So we're going to find his distance and his displacement from riding his bike around the block once. So the distance that Frederick traveled is going to be 1/4 mile plus a 1/4 mile plus a 1/4 mile plus a 1/4 mile. So equals 1 mile. Okay, easy enough. 4 quarters makes $1, whatever. So then how far displaced he was when he started, from his starting point when he came back home, is going to be actually, since he's starting at the same, so he's ending up at the same place he started. So like if you were to take a snapshot where he started, where he ended up, it's the same place. So his displacement is 0. 0 miles. Okay, so next one, we have Regina the cat sitting on her sunny back porch, and she creeps across the yard to check on a nest of baby rabbits. And when they flee, she walks back towards the porch 50 feet. So we're going to find distance and displacement. So it's always really important to have a visual in your mind of what this looks like. So I did that for you in this slide. I drew each one of these so you can see what's going on there. So she walks 150 feet this way and then 50 feet that way. So her path length, her distance, is going to be 150 plus 50, so 200 feet. Distance is always like the total distance, the path length, like how many steps you took basically. But displacement is going to be different. So 150 feet and then 50 feet back towards the porch. So if you were to take a snapshot of her here and then here, she has been displaced 100 feet because 150 minus 50 is 100. Okay? So then we have this squirrel, and his name is Sengo. And we're going to find the distance that he traveled up through the trees because Regina is blocking him from coming down to the ground. So he's just going through the trees to get to his friend. Finding distance and displacement. Okay, so he goes 20 feet north, 35 feet east, and 20 feet south. So the distance is going to be 20 feet plus 35 feet plus 20 feet. So I could be like 40 plus 35. So hold on, let me grab this good red writing right here. Copy, paste. So 75 feet total of distance when we add it all up. But displacement, so if we were to take a snapshot of him here and then here, he really only traveled 35 feet east. With displacement, it doesn't matter how he got there, but just he started here and he ended up here. And the direction is important. So we're going to say 35 feet east for this one. 35 feet east. Okay. So then we have Papase the woodpecker. So we're going to find he is migrating south. So 800 miles south and 300 kilometers. Oh man, I mixed it up here. 800 kilometers south and 300 kilometers east. What did I say down here? I did miles. Well, okay, we'll say miles then. So 800 miles south, 300 miles east. So the distance is going to be 800 plus 300. We're assuming that he's traveling in a straight line south and then a straight line east. So that's going to be those two added together, 1,100 miles. But if he flew in a straight line from Lansing, Michigan to wherever in Texas that is, then we would actually need to use the Pythagorean theorem there. And this is possible because we're working with a right triangle. Obviously not in like real life, it's not necessarily going to be always a right triangle. But for the purposes of what we're doing here, that's what it is. So this question asks, is his displacement greater or less than the distance that he traveled? So the displacement is always going to be less. The rule for the Pythagorean theorem is that the hypotenuse of a right triangle is always going to be less than the sum of its sides. So this is always going to be a smaller number than these two added together. So in order to solve that, let's look at how we're going to do this. So I'm going to copy this here. So it's going to be, the Pythagorean theorem says a squared plus b squared equals c squared. So 800 is one side, 300 is another side. And then to find this number, I'm actually going to go to desmos.com scientific. Yep, that's the one. And Desmos is just like a good general online calculator. You can use it for anything. Super helpful. So 800 squared plus 300 squared. Okay, so 730,000 is what those two things squared are. And then to get the actual answer, it's going to be square root of the answer. So it's actually going to be 854 miles is the hypotenuse there. So I could say 730,000 and the square root is going to be 854 miles. So distance, 1,100 miles. Don't forget to put units there. Displacement is going to be 854 miles. And we are going, oh my gosh, and do you know what else I did on this one? Oh my gosh. I wrote east and it actually is pointing west. So whatever, south, east, southwest, whatever you want to write there is totally fine. Goodness gracious. Okay, so then we have this otter. So this otter is going back and forth across the river, and we want to know the distance that he travels in one trip, and we want to know the displacement that he travels, or she actually. So the distance, so 50 meters each way. So 50 plus 50 is 100 meters. But the displacement, she's starting right where she's ending up right where she started. So this is another one where there is 0 meters of displacement. That'd actually be pretty hard to do on a river, but that's okay. Okay, so then we have this fox. And Waukesha, the fox, is walking 2.5 kilometers north and then 1 kilometer west to reach the napping spot in the meadow. So the distance is going to be 2.5 kilometers plus 1 kilometer. So that's going to be 3.5 kilometers. And then the displacement is another one where we're going to need the Pythagorean theorem. So I'm going to go ahead and copy this, duplicate slide. I'm going to bring this down here. Okay, so now we're looking at 2.5 kilometers squared plus 1 kilometer squared. And let's head over to Desmos and find out what that is. So clear all, 2.5 squared plus 1 squared equals 7.25. So that's not our answer. We got to do the square root of the answer. So 2.7 is going to be our thing here. 2.7 kilometers. I guess I should do one more line there. Equals 7.5, and then the square root of that equals 2.7. Okay, and then so the distance here is 3.5 kilometers, and the displacement is 2.7 kilometers. Okay? So then we have a bear, and this bear is lumbering around a blackberry patch. She munches for 18 feet to the north, 10 feet to the east, 14 feet to the south, 2 feet to the west, and finally 4 feet south before she falls asleep underneath a big maple tree. So I have added in some graph paper for you. Here's what you need to do here. We're going to draw some arrows. So I'm going to say this is my 0, 0, but first thing I need to do before I do anything else is I need to label my numbers. So this one goes up to 20, so I can actually use a 1-to-1 ratio here. So I got my 0, I got my 5, I got my 10, 15, oops, and 20. And that is feet. And then I can copy and paste this, and I'm going to turn it to the side. And it fits just right. Okay, so here comes my lines. Starting at 0, 0, I'm going to go 18 feet to the north. And I actually posted this in case you don't remember directions. Obviously, I made that mistake with the woodpecker earlier, but this will work for you. Okay, so I'm going to make it a nice bright red color, make it thick so you can see it. Woo, maybe not that thick. How about this thick? Okay, so there's 18 feet north, then 10 feet to the east. I'm going to start right there. There's 10. Okay, then 14 feet to the south. So, okay, so there's 3, 6, 9, 12, 14. Actually, I think it's right there, actually. 2 feet to the west. And 4 feet south. So it looks like it'd be hard, but it actually is not hard. Okay, so yeah, so the distance that the bear traveled is 18 feet plus 10 feet plus 14 feet plus 2 feet plus 4 feet. So equals 48 feet. And the displacement is just going to be 8 feet to the east. Okay? Cool. That's that. That's the thing. Nice work. You're done.